Okay, so we're doing Math 30-2, counting methods, and we're doing topic 6, combinations. Our goal is to determine the number of combinations of n objects taken r at a time. So let's explore this idea with the following question. In how many ways can positions be filled or a committee be formed? So number 1, from 3 candidates, Sue, Kim, and Ryan, in how many ways can the positions of president and treasurer be filled? So we're filling the positions of treasurer and president. So let's just list our possible outcomes. So if we have president and we have treasurer, and so we could have Sue as president and Kim as treasurer, Sue as president and Ryan as treasurer. We could have Kim as president and Sue as treasurer, or Kim as president and Ryan. Then we could have Ryan as president with Sue, or Ryan as president with Kim. So when we look at all that, we have 6. Now, we could also use our permutation formula to find that same answer, right? We have 3 people, but we're picking for 2 positions. So that would be 3, pick 2, which when we figure out, we also get 6. So that's if we're using the permutation formula. Now, what if, however, it didn't matter what their position was? There wasn't president and treasurer, but we have our 3 candidates, Sue, Kim, and Ryan, and we want to make an executive committee of 2 people. So looking at that, we want to say it doesn't matter if they're president and or treasurer, they're just members of an executive committee. So let's list our possible outcomes there. Well, we could have Sue and Ryan. That's one possibility. We could have Sue and Kim. Or we could have Kim and Ryan. So when we list those, where it doesn't matter whether it's president and treasurer, the position does not matter. It's only 3 possibilities. Now, the answer to the question is the number of combinations of 3 objects taken 2 at a time. We can represent this as a combination as opposed to a permutation. And combinations happen when position doesn't matter. It's not a first, second, third in a race. It is not a president, treasurer, vice president. It is just a group or a committee. So we're just gathering a group. So in this case, we represent that as 3C2. What operation would you need to perform to the calculation of 3P2 to get that value of 3C2? So let's think about what we had. We had 6, and we want to get to 3. So 6 to 3, we would have to divide by 2. So 6 divided by 2 equals 3. So that means to get from, I'm going to change the order of these, to get from P32 to 3C2, I would divide by 2. Okay, that would get me from one to the other. Now we're now talking about combinations. And what you notice is when you use, and I did this when I did the video for the instructions for how to put in permutations in your calculator. I also did how to put combinations in. It's the same menu, except it's one step down. So a combination is a grouping of objects where order does not matter. It's just a collection. So instead of 3 pick 2, we say 3 choose 2. The number of combinations is from a set of n different objects where only r of them are used in each combination. And we can represent them by NCR, or we can write it as n bracket over r. So those are the 2 ways that we can write that. And we calculate it with the following formula. NCR is equal to n factorial over r factorial times n minus r factorial, where r is greater than or equal to 0 and less than or equal to n. So it can't be bigger than n, and it has to be, it can't be a negative number. So let's just list that. So no negatives for n and r. Okay, I should write a lowercase r just to be consistent. Right, that's important. Okay, so let's do some examples to see how this works. Use the combination formula to manually calculate. Use your calculator to check your answers. So we have 10C2. Using our combination formula, that means that we have 10 factorial over 2 factorial times 10 minus 2 factorial. So this will be 10 factorial over 2 factorial, 8 factorial. Remember, we can rewrite 10 factorial as 10 times 9 times 8 factorial, all over 2 factorial, 8 factorial. We're manually calculating here. The 8 factorials divide out. So I'm left with 10 times 9 over 2 factorial, which is equal to 45. Okay. And 2 factorial equals 2, right? So because it's 2 times 1. Okay. Alrighty. Now, we also said we could write it like so, 8 over bracket 8 over 3. So if we're going to write that, we would write that as 8C3. Okay, now let's use our formula. So we'd get 8 factorial over 3 factorial times 8 minus 3 factorial, which is equal to 8 factorial over 3 factorial. 8 minus 3 is 5 factorial. We can expand that out. 8 times 7 times 6 times 5 factorial, all over 3 factorial is equal to 6, because it's 3 times 2 times 1. And we have 5 factorial, which we're going to divide out. And then we get, as our final answer, 8 times 7. We can also factor out that 6. Woohoo! So we get 8 times 7, which is 56. Now, use your calculator to check these answers, right? So you're going to use the same, it's pretty close to what we did doing permutations, except the big thing is you select number 3 instead of number 2 when you get to that final menu, okay? To do NCR. So put in your, for the first one, put in your 10, then go to the math menu, select the PRB menu, and then select number 3, and then put in your 2. And you should get 45. Do the same with the 8 and the 3. Put in your 8, go to the math menu, select the PRB menu, and then select number 3 and put in 3. And you should get the correct number. Okay? Alrighty. Let's do some more combinations to see how they're different, because they are different from permutations, and you need to know the difference between them. With combinations, order doesn't matter. Here we have one. At a birthday party, there's a bowl containing 10 different candies. Danielle wants to give 3 items to her friend Krista. How many different candy combinations can Danielle select for Krista if she wants each candy to be different? Okay, so we have 10 different candies. We just want to choose 3 of them. So we're going to take that. It doesn't matter what order they're in. They just have to be 3 different. So it's going to be 10 choose 3. We can do that in our calculator, or you can do the formula 10 over 3 factorial times 10 minus 3 is 7 factorial. And you would get 10 times 9 times 8 times 7 factorial over 3, 3 factorial equals 6, right? 6 times 7 factorial. The 7 factorials will divide out. And you will get as your final answer 120. Okay? But again, you can just stick that in your calculator and get your answer. So why not do that? Okay? Right? As long as you understand how it works. Now, what is the criteria if one must be a lollipop and the other two candies must be two different kinds? So for the next question, we have one is a lollipop and the other two are different kinds. So we'll have a 1 for the lollipop, right? And then for the other one, that means there's 9 other different candies and we're choosing 2 of them. So 1 times 9, choose 2, and we get 36. Again, you can do that manually if you like, or you can leave it as is. Okay? Drawing lines, triangles, and diagonals. Given 6 points with no 3 collinear, that is, there's no 3 points lining up. So I've got this circle and we don't have 3 that are in a row. How many lines can be drawn through the points? So for example, I could do this, I could do this, I could do that, right? So I have 6 points in total, and the most with a straight line I can join is 2 points. Because I could also do, I could do a line like this or a line like that, but I can't join 3 points together. The most I can join is 2. So I have 6 points, and the most I could join is 2, which would give me 15. The next question says, how many triangles can be formed with points as vertices? So if we are making a triangle, we are now using 3 points. And it doesn't matter where we do those 3 points, but we're connecting 3 points, right? So we're connecting them. So we have 6 points in total, and we're choosing 3 points to connect. When I do that, I get 6 choose 3, and I get 20 as my answer. Okay? All right. We can now use this to find the number of diagonals in a regular hexagon. Now, a diagonal has to go across the hexagon, so it does not include a side. This is not a diagonal. Okay, that is a side. So what it includes is like from one point here across, or from one point over here, or I could be connecting these 2 points, right? Those are all diagonals. There's a diagonal, there's a diagonal. Well, we don't want to have to draw them all. So what we have to do is we have to kind of take a look how many points. 1, 2, 3, 4, 5, 6. Okay. So we have 6. Oops, sorry. 6. And we're connecting 2, but we're going to have to delete some. So let's see how that works. So we have 6 points, choosing 2, and from 6 choose 2 we get 15. However, we have to subtract the number that are sides. So I have 1, 2, 3, 4, 5, 6. So I'm going to subtract the sides. So because they are not diagonals, but they still meet that 6 choose 2, right? So when I subtract those 6, I get 9 as my answer. So that one you have to do a little bit of thinking because there isn't 15 diagonals. There are 15 connections between 2 points. So we figure out the total number and then we subtract the sides or edges. Then we get all of our diagonals. Okay, Little bit of thought thinking there. Thought thinking. Okay. Solving a combination problem using the fundamental counting principle. So let's think about this. From 5 girls and 4 boys, how many committees of 3 can be chosen? First of all, without restrictions. Okay, so we haven't restricted how many. We could have a committee that's 3 girls. We could have a committee that's 3 boys. There's no restrictions, right? So in total, we have 9. And we're going to choose, the committee has 3 people. So we're at 9, choose 3. I'm going to rewrite that 3 because it looks a little hinky. So 9, choose 3, and we get 84. Okay. Now let's start looking at some restrictions. Consisting of 1 girl and 2 boys. Well, now we have to split it up a bit. We have to think about how many girls and how many boys we have. So we have 5 girls. So we got 5, choose 1 for the girls. Times, and we have, how many boys do we have? We have 4 boys, and we're choosing 2 of them. So when we do this calculation, 5 choose 1 times 4 choose 2, and we get 30. Okay, and you can check that on your calculator, what you get for that. 5 choose 1, I believe, is 5, and 4 choose 2 is 6. So it's 5 times 6, which equals 30. Okay. I just want to double check my math there because it never hurts. Yep. Okay. Alrighty. Now, so that's our first restriction. Now here's our second restriction. If 1 girl in particular, Tatiana, must be on the committee. So that means that we have 1 person, Tatiana, and then the remainder, which is, we now only have 8 children remaining, and the committee has 3. Well, we already have 1 of those positions filled, so it will be 8 choose 2. So we would get 28 for that. Okay. Now let's look at the next restriction. If 1 particular girl, Tatiana, must not be on the committee. Okay. Now, we already know what the options are if Tatiana is on the committee. So let's look at what it is if she isn't. Well, if she isn't, that means we're only picking from 8 people. So 8 choose 3. 8 choose 3 is 56. However, if we go back and we think about how many we could, when we had 9 choose 3, 9 choose 3, that was like the total, including all of them, that was 84. If we take 9 choose 3 and we subtract the number that we got when Tatiana had to be on the committee, which was in the number C, which was 8 choose 2, so we go 84 minus 28, we get 56. So you can take the total number and subtract the ones where she is on the committee, and it should equal to the number where she's not on the committee. Interesting. They connect, right? They're kind of connected counting terms. So let's take a look here. More information. Sometimes combination problems involve cases. For example, we use the phrases like at most or at least, just to kind of show that we might have more than one possibility. Remember when we talked about this with permutation with the flags? Well, the same thing can happen with combinations. So we really need to read those questions carefully. The expression at least or at most indicates that there are more than one possible outcome. When you're calculating your answer, the word and implies multiplication, and the word or implies addition. We've talked about that. So and implies multiplication, and or implies addition. If we're using terms like at least and at most, that means we're going to have different possibilities, and we're going to be adding. Okay? So generally speaking, if you have at least and at most, you're going to be adding the different cases together. It's good to think through them and just really kind of think about which applies. Now, some of these questions can be calculated indirectly by considering the cases that do not meet the conditions and subtracting that from all possibilities. That's what we did with Tatiana's situation. So instead of doing a new calculation for that combination, you can say, okay, well, I can't figure this out, but I know what does fit that restriction, so I'm just going to subtract it, okay, to get those that don't. Okay. Let's do more examples. Example number 5. Solving a combination problem by considering cases. Jared is making a tossed salad for dinner. In his refrigerator, he has 5 vegetables to choose from. How many different salads can he prepare if he uses at least, at least 3 different vegetables? So he has 5 in total. So the minimum is if he has at least 3. So he could have 3 veg, he could have 4 veg, or he could have 5 veg. So we have to think about all of them, and it's an or, so we're going to add them together. So for 3 veg, he has 5, choose 3, or he could have 4 veg, which is 5, choose 4, or he could have 5 veg, which is 5, choose 5. Figure out each of those, and you add them together, and you get 16. And just to double check, 5, choose 3 is equal to 10. 5, choose 4 is equal to 5. And 5, choose 5 is equal to 1. So we add those together, we get 16, right? That's just to make sure you're doing that right with your calculator. Try them. Now, what if he had at most 3 vegetables? So slightly different question. Okay, so at most he had 3 veg. So what we're going to have for that one is he could have 3 veg, or he could have 2 veg, or he just has plain old cucumber, 1 veg. What a salad. Okay, so 5, choose 3 for 3 veg, plus 5, choose 2 for 2 veg, or 5, choose 1 for 1 veg. 5, choose 3, we know from the previous one, is 10. 5, choose 2, let's figure that one out. It's equal to 10. And 5, choose 1 is equal to 5. So he has 25 options. Okay? So it's important to figure that out. Now, I want you to notice that 5, choose 3 and 5, choose 2 actually give you the same number. That's going to occur because 2 plus 3 equals 5. So whenever you have those kind of paired numbers that add up to the total number of options, they actually will equal the same amount. So 9, choose 5 is equal to 126, and 9, choose 4 is equal to 126. So it's kind of interesting there what happens with the choosing. So just be aware of that, okay? Just have it in your head. It's a neat trick. So need to knows. When order does not matter. In a counting problem, you are determining combinations. So order does not matter. You're just collecting a group of things. You don't care what order they're in. So they're not lining up for a fountain. It's 3 kids are going to jump in a pool. Doesn't matter what order they're in. When all n objects are being selected, there is only one possible combination, right? If you have 9 kids and you want a group of 9, there's only one way you can fill that. So 9 choose 9 equals 1. 5 choose 5 equals 1. 4 choose 4 equals 1. Okay? 350 choose 350 equals 1. The number of combinations from a set of n different objects where only one of them are used in each combination can be noted by NCR, or we can write it like this. It's a tall bracket with an N over an R, and is calculated manually using this formula. Okay, so we did some examples with that, right? So we're familiar with this. The formula for NCR is the formula for NPR divided by R factorial. Dividing by R factorial eliminates the counting of the same combination for R objects arranged in different orders. So when you divide your permutation by R factorial, then order doesn't matter. Okay? From a set of n different objects, there's always fewer combinations than permutations. So combinations are always going to be smaller than permutations. And when a combination involves conditions, you can solve it directly or indirectly. Directly, you consider the cases that reflect the conditions and determine the number of combinations for each case. And then you add the results to determine the total number of cases or combinations. And indirectly, you determine the number without any conditions, and then you consider the cases that do not meet the conditions and figure the number of combinations for each case identified in step 2, and then you subtract. So there's 2 different ways to get to the answer when you're dealing with restrictions, and for different situations you're going to choose to use different ones. Okay, so that's combinations. Very similar situation to permutations, but now we're dealing with no order, and you really are going to have to learn to determine the difference between each one. So you have to read your questions very carefully to tell, is this a combination or is this a permutation? So you have to ask that question. Does order matter, or is it just a group? Okay.